In this short little video, I want to show you some intuition about the instantaneous rate of change and the average rate of change, or the slope of the tangent line and the slope of the secant line, using an applet I found at the Math Insight page. So Math Insight up here at the top, I'm at mathinsight.org/applet/secant line slope. And here you get to type in a function. In green, I have here the square root function, and I have in this purple dot on the left, that is my point P. It's at 1, 1, and I'd like to find the slope of the tangent line there. And this little applet will do some computation for me. What it's going to do is find the slope of the secant line between my point P here at 1, 1 and my point Q over here, this little green dot. And as I move this green dot, you'll see delta Y over delta X will be computed. If my point P is at 1, 1 and point Q is at 6, 2 point something, appears that the slope is about 0.290. What is the slope of my green curve right at this purple dot? I want to know what the slope of the green curve here, the square root function, is at the purple dot, and I can get an approximation by moving the second point here, Q, closer. As I do that, notice that the slope numbers change. I'm now at 0.315, 0.333, and so on. These slopes are getting closer and closer to the true value. My secant lines are slowly becoming the tangent line. We seem to be about 0.472. This red secant line is 477. And then about the time 496, about the time the slope might be 0.5, everything disappears because my point Q has become my point P and there's no line to draw. Let's go on the other side. On the other side is my point Q. Let's take Q all the way down here to the origin. Right here now the secant line, that red line slashing through the 2 points, the green and purple one. This red line has slope 1. Now let's move it up slowly toward the point P. Notice that my delta Y delta X above is 0.576, 0.564, 0.5 something. It's getting closer and closer to 0.5, getting closer and closer until I hit, and it disappears in a moment. Looks to me then that that tangent line must have slope 0.5 or a half. So the slope of the curve, this a square root function, the slope of this curve, x to the minus 1 half, at the point where x is 1, seems to be a half. And I got that by taking secant lines as a point Q moved into this point, to the purple point. That is the concept that the IRC is the limit of the average rate of change as the second point Q moves toward P, or the slope of the tangent line is the limit of those secant lines.